What is up, guys? Today we're doing a question that was recommended by Nick Figgins. Thanks for the comment, Nick. If you guys have any other videos you want me to do, just put them in the comments down below. This question is currently being asked by Facebook, Amazon, and Google, and it is called Jump Game. Let's get to it. What's up, guys? Today we're doing a question currently being asked by Facebook, Amazon, and Google, and the question is Jump Game. The problem description is, given an array of non-negative integers, you are initially positioned at the first index in an array. Each element in the array represents your maximum jump length at that position. Determine if you're able to reach the last index. We get two examples. Example 1 is input 23114. The output's true because jump 1 can be from the 0th index to the first, and then you can jump 3 steps to the last index. You could also just jump 1 step at each index, because the value at each index is just the max jump you have to take. And then the second example is 32104, and the output is false because you'll always end up at the third index. So the first way that I thought of this is that you could represent the indices and then the max jumps as a graph where you could just try to find the path from the 0th index to the 4th index and then memorize bad paths. And this essentially is backtracking plus memorization, which is dynamic programming. But the problem is I coded it up, and this would pass 74 to 75 tests, and then timeout for the last approach. And then when I did a bottom-up approach, I also got 74 to 75 tests. So I started thinking, how can I use some similar property every time that I can just always look at the maximum jump rather than looking at all the possible jumps? And this is called a greedy algorithm. The greedy choice property is the property of me always wanting to choose the largest jump. So at first, when I was thinking about this, I started thinking of this example, and I don't want to be able to reach this kind of case where I'm walking through the array and then I reach this 5 and then I jump to here and then now I'm stuck because this 8 would be able to get me through. So rather, I want to run this greedy choice algorithm, but I want to do it walking back through my array and keeping track of my end, which represents my search space. So my end right now is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll just decrease this. 0, 1, 2, 3, 4, 8. So my end is 8, which is actually 7 now because of the 7th index. So I walk backwards, see if this can go past 8. It can't. See if this can go past 8. It can't. And then I see that this can go past 8. So at the 4th index, this can go past 8. So 8 reduces to 4. And then now I reduce my search space. So I'm only looking at the first 4 indices. So I see if 0 can go past 4, it cannot. I see if 0 can go past 4, it cannot. I see if 5 can, it can. So I reduce my end to this 5 at the first index, and I reduce my search space to 1 and 5, and 1 can reach the first index, so I reduce my end to 0, and I return if n equals 0. So then the way I do this is I'd set my end to my len nums minus 1, iterate backwards through my array, and then if current index plus val at current index is greater than or equal to my current end, update end to current index. So this is really simple. It has a time complexity of O of n and a space complexity of O of 1. So I think this would be good to code up. So end equals len nums minus 1 for I in, and then I need to do reverse because I'm walking back through the array. Reversed len nums minus 1, and an integer is not an iterable, so it needs to be len range or range len. So now I can say if I plus nums at I is greater than or equal to, greater than or equal to end equals I, else I keep going, and then I return my end equaling to 0 at the end. So let's see if this works. Awesome, and it does. And let's see if this works on everything. Cool, so that worked. So if you guys have any questions, just leave them in the comments down below. This was a really good example of a greedy algorithm, and if you want me to do any more greedy algorithms in the future, just leave that in the comments down below. Thanks so much for the problem recommendation, and I'll see you guys soon. Peace.